Hi all, a warm greeting to each and every student who is watching this video from ANC team. In this particular video, in this particular session, we are going to discuss a very important topic on mensuration. Initially, let us discuss some beautiful techniques or beautiful shortcuts or beautiful analogies that we can implement in solving mensuration problems for a two-dimensional figure. Later, after learning all the beautiful techniques in two-dimensional figures, let us switch on to mensuration three-dimensional figures. This is what we have in mensuration. We have two types in mensuration. If I call it as mensuration, mensuration is classified into two types. First thing is it is a 2D figure representation, and the second thing is it's a 3D figure representation. In my 2D figure representation, I will be more interested in finding the length and breadth of the given figure or whatever it is. In my three-dimensional representation, I'll be interested in finding length, breadth and also the height. These are the three parameters which are present in three-dimensional representation. Similarly, in two-dimensional representation, I will be interested in finding the area of that particular figure. Similarly, in three-dimensional, I'll be interested in finding the volume. I'll be interested in finding the volume of that figure. In 2D, I'll be interested in finding the perimeter of that particular given figure. Perimeter of that figure is what I need to find. In three-dimensional, I'll be finding total surface area. I'll be finding curved surface area. What is the meaning of this total surface area? What is the meaning of curved surface area? Everything we will understand in detail step by step when we come to three-dimensional figure in mensuration. But our main focus at this present moment is on mensuration 2D figures. That is what our heading also says here. Mensuration 2D is what we are very much interested in understanding at our present scenario. Now, what are the things which are available or which are actually there in mensuration 2D? Which are the figures which you are talking about? They are saying that in mensuration 2D we are going to talk about the area of a figure, perimeter of some figure or whatever it is. Which type of diagram or which type of representation, geometrical representations which you are talking about? There are some representations or there are some geometrical shapes. Let us see one by one. We will understand, probably not too much in detail, because these are things which we will solve it in detail in our geometry class. In mensuration, we will understand probably what is required for our examination perspective. First thing what we are interested, first geometrical figure which we are interested in learning is it's the square. What is the meaning of this square? I am sure that everyone knows this. Diagram is not drawn to the scale, so this is the square. If I name this square as ABCD, if I name this square as ABCD, the beauty about the square is you take any side, you take this side AD, this side AD, the length of the side AD will be equal to the length of the side AB. Similarly, the length of the side AB will be equal to length of the side BC. And similarly, the length of the side BC will be equal to length of the side CD. In simple language, in a square, all the sides will be 100% same. They will not differ even by 0.01 percentage also. If it is differing, it is not considered as a square. The diagram is not drawn to the scale. Maybe it is not exactly equal in all the cases in the diagram whatever I have written. But a square is basically a quadrilateral. What is the meaning of quadrilateral? Quad. QUAD, quad is nothing but four-sided figure. Quad is nothing but 4. Tri is nothing but 3. TRI, tri. So it is nothing but 3. So it is a quadrilateral. Square is also a quadrilateral, which is a four-sided figure where all the sides are equal. All the sides are equal. In simple language, if the length of this geometrical figure and the breadth of that geometrical figure, if the length and breadth of two geometrical figures are same, then it is said to be square. I hope the idea is clear, sir. Then it is said to be square. Now, this square, whatever we have, suppose if I call the side AB as A, Side BC also will be A. Side CD also will be A. Side AD also will be the same A centimeters or A meters, whatever it is. Now, this square has some area which I am shading right now. What is the area of this square? We are not interested in teaching or learning the proof of all these areas at this present situations. Let us only know let us only understand what is required. Area of the square is side into side. Side is nothing but A. Another side is also A. So area of the square is nothing but A square. Sir, I want to know the perimeter. What is this perimeter? Perimeter is nothing but sum of all the sides. If I add this side AB with my another side BC, again with my another side CD, again with my another side DA, if I sum all the sides, sum of all the sides of any geometrical figure is known as perimeter. That means perimeter of a square is A plus A plus A plus A. It is 4 times of A. I hope the idea is clear. Perimeter of a square is 4 times of A. These are all some things which many students are aware of it already, but I want to recap it once before we start solving some basic questions initially, slowly scaling up to some higher level questions also which had come in your examinations. We are mainly concentrating in the entire topic of mensuration, whether it is 2D or 3D. The idea is to solve many questions which had come in the examination, be it bank exam or SSC exams or some of the CAT examinations also. Now, I understood the area of the square. I also came to know about the perimeter of a square. Suppose I want to find the diagonal. Diagonal in this case is nothing but BD, or diagonal can also be AC, right? What is the length of the diagonal? Diagonal is given by, I am definitely sure that you all know that Pythagoras theorem. I will anyway come back to it when I take right angle triangles. Diagonal of a square is nothing but, this is the hypotenuse. First of all, when it is a square, each and every angle is subtending an angle of 90 degrees. So angle C is 90 degrees. If angle C is 90, this CB is one of the side A. CD is another side, that is also A. So BD is what we are finding, that is nothing but diagonal. Hypotenuse square or diagonal square is nothing but BC square plus CD square. It is A square plus A square 2A square. But I want to find the diagonal. Diagonal is nothing but square root of 2A square, or in other language, diagonal of a square is nothing but root 2 into A. I hope the idea is clear for you, sir. I am damn sure that it is not difficult to know all these things, because these are some things which we have learnt from so many years. These are some of the things what we have learnt from our school days. So I don't think that my students will be facing difficulty in understanding these simple concepts. But I can also say that you are already aware of these things, but I definitely do not wish to start my class without teaching all these basics. Whether you know it or do not know it, my responsibility is to teach you people initially, and then take it forward for some basic level questions initially, and then some extraordinary higher level questions which were original examination questions. Let us carry that step by step procedure, sir, because I always personally believe that the basic foundation is very much important for us to scale up to higher level questions. That is what I have taught in almost all the topics whatever I have taken. I do not want to break my rules. So is the case with my students also. I hope the first geometrical figure what we have learnt is clear for you people. And the second geometrical figure, which is an extension of square, which you people already again will be aware of, is rectangle. Sir, what is this rectangle? Very simple. In square, all the 4 sides will be equal, or in simple language, length of the square will be equal to breadth of the square, right? Length will be equal to breadth, then it is called as a square. But in rectangle, opposite sides will be equal. That means AB and CD will be equal, AD and BC will be equal. If I make this AB equal to AD and DC equal to AD, then this rectangle will eventually become a square. That is what you can easily represent it as. I hope the idea is clear. This is my length of the rectangle. Sir, should I call this AB itself as length? No, you can take AD also as length. If one of them is length, then the other is breadth. Or in simple language, if length is equal to breadth, it becomes a square. If length is not equal to breadth, it becomes a rectangle. Rectangle is also a four-sided figure. Rectangle is also a quadrilateral where length is not equal to breadth. Square is also a quadrilateral where length is equal to breadth. That is the only difference between length and breadth. And as I already said you, opposite sides in rectangle, they will always be equal, right? They will always be equal. And what will be the area of this rectangle? I already told you that area of rectangle, area of square is side into side. Here also it is the same thing. Rectangle is also a square, but only little difference is length becomes not equal to the breadth in this case. That's all. That means here also area is side into side. One of the side is L, that is length. Another side is breadth. So area of rectangle is length into breadth. Let us not go in detail about the proof of all these things at this present moment, which we have probably learnt in our school days itself. Sir, what will be the perimeter in this case? Then again it's very simple, sir. Perimeter is nothing but sum of all the sides. So this side is length. CD is also length. It is length plus length. It is 2 times of length. BC is breadth. AD is also breadth. It is 2 times of breadth. So it is 2L plus 2B. Or if I take 2 common factor, okay, let me write it. 2L plus 2B. It is 2 times of L plus B, right? This will be the perimeter of a rectangle. Similarly, can you please teach me what will be the diagonal? The length of the diagonal, can you please tell me what will be it, sir? Length of the diagonal, again it's very simple. BD is the diagonal. Rectangle also, each and every corner will subtend an angle of 90 degrees. So this is 90 degrees. This will be length. This will be breadth. BD is hypotenuse. Hypotenuse square, diagonal square is equal to L square plus B square. But if I want only diagonal, shift that square to the right hand side, it becomes square root. Diagonal of a square root is diagonal of a rectangle is nothing but square root of L square plus B square, where L is nothing but the length of the rectangle, B represents the breadth of the rectangle. I hope the idea is very, very clear for you people, sir. I hope you are understanding the logic behind solving. Similarly, in this case, I told you about the diagonal of a square, right, sir? So diagonal of a square is nothing but root 2 into A. Suppose if I square it on both sides, diagonal square is equal to 2 into A square. That is what I have written here also, right? Diagonal square is equal to 2 into A square. Now, same logic. Diagonal square is equal to, what is A square? A square is nothing but area of the square. So it is 2 times of A. In place of A square, I will write capital A, which represents area. That means the relationship between diagonal and area of a square is given by D square is equal to 2 times of A. Sir, should I by heart all these formula? Definitely no, not required, sir. It is definitely not required to by heart all these formulas. Maybe some basic representations. What is the length of a square? Length into length. That means side into side, which is nothing but side square. That is something which basic analogies or basic representations, if you know, that is enough. You don't need to by heart each and everything. First of all, we hate something in Anil Nair classes. That's something what we hate the most in A&C is nothing but formula based learning. Yes, unfortunately in mensuration, it is very difficult to solve all the questions without formulas. Yes, we will use formulas in mensuration, no doubt about it. But we will not use formula to a greater extent. Wherever there is no requirement of formula, we will avoid it. Wherever there is no requirement of variable usage, we will avoid it. We will solve it in completely different methodologies, so that you will understand how you should actually solve a mensuration question without by hearting so many formulas which are available. Let us understand only the basics of all these things with basic formulas like or basic representation like what is the area of a square, perimeter of a square. No need to know, sir, should I definitely remember the relationship between diagonal and the area of a square? No, not required. You can derive it when required. I hope you are understanding, sir. You can derive it when required. That does not mean that you should by heart those things. This is something which you should be aware of. Next, two geometrical figures are over. Next, another very very popular geometrical figure which every student will be heard of is triangle. What is the meaning of triangle? Name itself suggests tri is nothing but 3. Angle is nothing but angle itself. If a geometrical closed figure is having 3 angles, if there are 3 angles, definitely there should be 3 sides also, right? If a geometrical closed figure ABC is having 3 angles, angle A, angle B, angle C, then the geometrical closed figure is said to be a triangle. And I am damn sure that you know the basic, you know all these basic properties of triangles. One of the very very important properties of triangle is sum of all the 3 angles in a triangle is always 180 degrees. Sum of all the 3 angles in a triangle is always 180 degrees. Sir, can you just tell me the proof of this in a very simple language? Yes, we don't need to have the proof like the way it is given in our school textbooks. A small proof for you people. Now see here, sir, this base BC, I will write it as it is, right? That base BC, I will write it as it is. Let me use a different color. Now this AB, I will shift it to here. I will shift it. This AC, I will shift it to the right side. If AB comes to the left side, if I shift it, the area will not change of a geometry. Area of a geometrical figure will not change. So here AB comes, right? Here AB comes. If I shift this AC to the right side, here AC comes, right? That means this is the extension. This entire line becomes a straight line. What is the angle in a straight line? Angle in a straight line is 180. That is what you have written here also. Simple, the most simplest proof of why sum of 3 angles in a triangle is 180. This will be the most simplest proof you could have ever heard about it. I hope the idea is clear. Now this is a triangle. Triangle is, there should be 3 angles, there should be 3 sides. Sir, should all the 3 angles be equal or should all the 3 sides be equal? There are different types of triangles again in such cases. First, one of the type of triangle what we can learn is a scale-in triangle. What is the scale-in triangle? One of the simplest triangle what you can have in scale-in triangle is none of the side will be equal. If sides are not equal, angles will also definitely be not equal. Now this is angle A. The side which is opposite to angle A is BC. The side which is opposite to angle A, I will call it as small letter A. Side which is opposite to angle B, I will call it as small letter B. Side which is opposite to angle C, I will call it as small letter C. That means angles will be different. Let me let me make them different. Angles will be different. Sides also will be different for a scale-in triangle. Now for this scale-in triangle where none of the angles are same and none of the sides are same, how to find the area? Again I am saying, sir, no need to go in detail for the proof of it. Area of a triangle, usually when none of the sides are same and when none of the angles are same, it is given by the notation square root of s into s minus a into s minus b into s minus c. Sir, what is that s? There is nothing we have mentioned in the diagram as s. What is that s? That s is nothing but take the perimeter of this triangle. What is the perimeter of this triangle? Sum of 3 sides. A plus B plus C is the perimeter. And that perimeter, whatever you are getting, you make it into half of it. That means S is nothing but semi-perimeter, right? Semi-perimeter is nothing but S. Semi is nothing but half. So S is nothing but perimeter by 2, or in simple language, S is nothing but semi-perimeter. Sir, I have seen this formula or whatever it is somewhere, sir. I don't remember where I have seen. There is some name for it. Yes, This particular notation of area is given by the notation or naming called as Heron's formula. You might have heard about it in your school days, sir. Please try to recollect whatever we have learnt. That is one of the reason we should never forget the basics of all the topics what we have learnt in school days. School is the foundation, but that school days methodologies we cannot apply in competitive examination, so we will tune it. We will tune what is required for our level right now. Right now our level is not a school level examination. We need to implement some beautiful shortcuts which will give us answer in little faster way. So let us implement that and little tune it what we have learnt in school days. But you should never forget what we have learnt, the basics which we have learnt in school days. I hope you are able to understand. This is one of the type of triangle, scale in triangle. Sir, is that the only way? No, there is something called as equi. What is equi? Equi is nothing but equal. Equilateral triangle means all the sides are equal. First triangle what I told is none of the sides are equal. Second triangle is all the sides are equal. That means angle A, angle B, angle C also will be equal in this case. That means opposite to angle A, if I call it as a small letter A, opposite to angle C also the side will be the same angle, side A. Opposite to angle B also it will be the same side A. I hope the idea is clear. If all the three sides and three angles are equal, then it is called as equilateral and equiangular triangles. Now if I drop a perpendicular, this will be the height of the triangle, right? This will be the height of the triangle. Height is nothing but from the foot of a human being till the top of the human being. Top is nothing but the top of your head. From the foot of the human being, this is the foot of that human being, and this is the top of the human being. That is nothing but height, right, sir? How do you calculate your height? You will stand in front of the measurement when it is sticked onto a wall or whatever it is, and you will check your height. You will not check it from your knees. You will check it from your foot, right? Similarly, you will not check it till the neck. You will check it till the top of your head. That is nothing but the height. Same is the case with geometrical figure, no change. So height is nothing but this A D, if I call it as AD, is nothing but the height. All the three sides are same, right? All the three sides are same. Now what will be the area of this equilateral triangle? Area of equilateral triangle is given by root 3 by 4 into side square. If I take the side as A, so root 3 by 4 into side square is nothing but root 3 by 4 into A square. Now if I continue further, sir, this is the height. Height is nothing but the perpendicular drawn, right? Height is nothing but the perpendicular drawn. That means this is subtending an angle of 90 degrees. This also will subtend an angle of 90 degrees. And because it's an equilateral triangle, this particular area will be equal to this particular area. It is dividing the entire bigger triangle into two equal half. Now you take any triangle. Suppose if I take this triangle ADC, angle D is 90 degrees. This side is nothing but A. This side is half of A because it is dividing equally. It is A by 2. If I apply Pythagoras theorem, so hypotenuse square A square is equal to adjacent square A by 2 whole square plus opposite square plus h square. Opposite is AD, which is h. Simplify. A square is equal to A square by 4 plus h square. H square will be equal to A square minus A square by 4, which is 3A square by 4. But I don't want h square. I want only h. Take the square root on the right hand side. Root of 3 will be written as root 3 itself. Root of A square is A. Root of 4 is nothing but 2. Very, very important point. Height of an equilateral triangle is always given by the notation root 3 by 2 into side, where side in this example is nothing but A. Sir, should I again by heart it? Not required. You don't need to remember everything, sir. One thing what you can easily remember is area of an equilateral triangle is root 3 by 4 into a square. But should I also remember height is equal to root 3 by 2 into a? If you can remember, it's good. But there is no need for you to put so much of extra pressure or so much of extra effort in by hearting all these formulas. When it is required within seconds, we will solve it in problems, which we will come to know in the next few minutes of our class. I hope the idea is clear till this point of a time. I hope you are understanding the logic, sir. The next type of triangle, what all happened till now, sir? Triangle is what we are discussing. In triangle, first type what I discussed is scale-in, second type what I discussed is equilateral, and the third type what I am going to discuss right now is right angled triangle. Right angled triangle. Now this right angled triangle, already while explaining some other triangles, I came across this right angled triangle and I have explained a little bit already. Anyway, you know very much about right angled triangle. We have discussed similarities of right angled triangles in our geometry class also. If there is a triangle ABC, if one of the angle is subtending an angle of 90 degrees, first scale in triangle, all the three angles are unequal. Equilateral triangle, all the three angles are equal. Right angle triangle, one of the angles should definitely be 90 degrees. Then only it is said to be right angle triangles. The sum of other two angles should be 90 again, right? The sum of other two should be 90 because total sum of a triangle should be 180, right, sir? So 90 plus something should give you 180. That something should also be 90, right? That means sum of the other two angles should give you 90. One of the angles compulsorily has to be 90 degree for it to be a right angle triangle. Now, if I call BC as my base and AB as my height, area of a right angled triangle, in fact area of any triangle for that matter, when we draw a perpendicular, area of a triangle can be found out as half into base into height, where base is nothing but a small letter b, height is nothing but a small letter h. I hope you are understanding the logic. And the Pythagoras theorem is applicable only for right angled triangles. What is the Pythagoras theorem? Opposite to 90 degrees is hypotenuse. This is your hypotenuse. Opposite to 90 is hypotenuse. Opposite to angle C is opposite side. Adjacent to angle C is adjacent side. That means Pythagoras theorem says that hypotenuse square is equal to opposite square plus adjacent square. Anyway, do not worry about all these things because in detail we have already solved all these Pythagoras theorem based problems in our geometry class. Let us not dig deep into it once again, which we have already discussed. Let us not waste our time. Basic understanding we will implement, sir. And please do not be in an assumption that whatever I am teaching you from the last few minutes are very much basics. Yes, definitely I will go through basics initially. If you are bored of listening to it, I think you will struggle in my upcoming problems. As simple as that. If you think that I know already all these things here, what is this person explaining once again in detail, so much time he is explaining, I will spend so much of time in making the base of the building very strong, because the base of the building, if it is strong, the building can be built to any height as much as possible, as much as required. That is the reason I want to make the base of the building strong, and I am spending so much of time for it. If you are not interested, you can move forward, you can listen to whatever you require, but I will never do like that. For me, every student is important. Starting from level 0 to level 1 to level 2 questions only I will take. I will not immediately jump to level 2 questions. If it is very much urgent for you people, you can skip this particular video and you can start watching the high level questions, but probably you will understand not that easily because you might have skipped my basic classes. Anyway, the fourth type of triangle is isosceles triangle. Sir, what is this isosceles triangle? Isosceles triangle means, scale-in means all the three angles are different or all the three sides are different. Equilateral means all the three sides are same. Right angled means one of the angles should be 90 degree. Isosceles means two sides will be same. Two sides, any two sides should be same. Suppose for example, if I call this triangle as ABC, AB I will make it same as AC. Opposite to AB is angle C. Opposite to AC is angle B. Angle B and angle C will also be definitely same in that case. I hope the idea is clear. That means if I call this BC as a small letter B, if I draw a perpendicular, this will be my height. Height I will call it as AD. For example, this will become B by 2. Right? This will become B by 2. And this side is B. Other two sides are equal. So I will call it as A and A. Both should be A and A itself. Now, if I calculate it, if I apply Pythagoras theorem for triangle ADC, hypotenuse square is A square is equal to H square plus B by 2 whole square. So A square minus B square by 4 is equal to H square. So height of the isosceles triangle is given by the notation square root of 4A square minus B square whole thing divided by 4, or height is given by square root of 4 is 2, half of 4A square minus B square under the square root. I hope it is very clear. A little bit of proof whatever I have given. But I want to find the area, sir. Can I find the area? Definitely, why not? Area is half into base into height. So this is half into base is nothing but B. Height just now we calculated half of root of 4A square minus B square. That means area of an isosceles triangle is, it is B by 4 into square root of 4A square minus B square. Very important, sir. It is very difficult to by heart all these formulas, sir. Who asked you to by heart, sir? Then why are you doing, sir? For your understanding, sir. I hope you are understanding. For me, I need to explain you people. For you, you need to understand. That does not mean that you should remember all these things. Sir, I can remember. I don't have any problem. I have so much of remembering capacity. Please remember. Sir, I cannot remember. I will forget. Whatever I have spoken 5 minutes before only I will forget. How can I remember thousands of formulas? Don't remember. We will see some other logic to solve all these problems in problematic way. I hope I am making sense for you people. I hope you are understanding, sir. Next geometrical figure after triangle is circle. Whatever I am discussing, everything is only the basics. Circle. Circle is nothing but a collection of so many points. Infinite points, you can say. In fact, circle is nothing but a collection of infinite points. There will be some midpoint for this circle. If I start my journey from this midpoint and if I reach any point in the layer of a circle, I will call this dotted line as a layer of a circle for time being. The distance I will call it as R. From the same center point, if I start once again, go to some other point which is at the layer of my circle, that distance will also be R. This distance will also be R. This distance will also be R. This distance will also be R. I hope I am making sense. That means this particular layer of the circle, what I am marking in black color right now, that is known as circumference. Sir, in triangle also this will be the layer. For this you called it as perimeter. Now you are calling it as circumference. Both are same, sir. Because it is a circle, you are calling it as circumference. Circumference, circle, circumference. The name is only the difference. That's all. Rest all the concept is same. Circumference is nothing but equal to perimeter. Both are 100% the same analogies. Right now, if I want to find the area of this circle, area of this circle is pi r square. Sir, what is this pi? Pi is nothing but 22 by 7, or approximately pi value is 3.14. Let us not go again too much detail into it. Now sir, how to find the perimeter, which is nothing but what you said as circumference? What will be the circumference of the circle, sir? Area of the circle is pi r square. Circumference of the circle is 2 pi r. How it is? Let us not worry about it at present time. I hope you are understanding. Sir, can you please tell me the diameter? Diameter of the circle. Diameter of the circle is nothing but, what is the meaning of diameter, sir? You start your journey from one end of the layer. That means one end in the circumference. You end your journey in the other end. Sir, can I start and end however the way I want? No. You should definitely pass through the center of the circle. If you are not passing through the center, it is not considered as diameter, right? Now in this journey, you are passing through the center of the circle. From here you started and you ended at the other layer of the circumference, but you are passing through the center. That is nothing but diameter. From here to the center it is radius. From the center to this layer it is again the radius. So diameter is radius plus radius. It is 2 times of radius. Diameter of a circle is 2r. So instead of this 2 and r, I can write it as d diameter. I will write pi as it is. So circumference of a circle is 2 pi r. Circumference of a circle is also given by pi into d. I hope this basic understanding is clear for you. Let us not go again too much in detail, because circles problem also we have solved many a times and many a questions in our, what do you say, like geometry class. I hope this is clear for you. Next type of geometrical figures is quadrilaterals. Sir, hold on, sir. Quadrilaterals you have already taught us, right? You told square is a quadrilateral. You told rectangle is a quadrilateral. Yes, you are bang on, sir. You are 100% right. The meaning of quad is nothing but 4. Any geometrical 4-sided figure is nothing but a quadrilateral. Any geometrical 4-sided closed figure is nothing but a quadrilateral. In quadrilateral, there are different varieties. One of them is square, which we have already understood it. Another is rectangle, which again we have already understood it. Another is trapezium. Yes, we will see what is this trapezium right now in the next 1 minute. Next one is parallelogram. Parallelogram also is a 4-sided quadrilateral. We will see that. And another what I can say is a rhombus. Like that there are there. So we will discuss these things in little detail, at least if not too much in detail. Square and rectangle is already over. Let us see what is this trapezium means, right? What is this trapezium? Now see here, sir. It is very easy, sir. It is very easy. Trapezium, it is a 4-sided geometrical figure which is a closed figure. In simple language, trapezium means trapezium. Okay, let me write the diagram first and then explain you people. Trapezium, if I call this trapezium as ABCD, right? If I call this trapezium as ABCD, simple language, if I want to say you people, in trapezium, 2 sides will be parallel. That means AB will be parallel to CD and another 2 sides will be non-parallel. AD will not be parallel to BC. Is AD and BC parallel? Definitely they are not parallel. AB and DC, are they parallel? Yes. Maybe diagram is not drawn to the scale, but they are actually parallel. That means if 2 sides are parallel and other 2 sides are non-parallel, then that 4-sided quadrilateral is known as a trapezium. I hope you are able to understand the logic. That 4-sided quadrilateral is known as a trapezium. Now think little logically, sir. Suppose for example, I will draw a perpendicular. This perpendicular I will call it as height h. This is my 90 degrees. From here also I will draw a perpendicular. This is again perpendicular. I will call the same height h. Both are same heights. Now this particular side and this, suppose if I name this as C, D, E and F. So AB and EF, they are parallel, and AB and CD are also parallel. In fact, AB and EF are also parallel, but because the height is same in both the case, AB is equal to EF. That means if I call AB as small letter A, EF will also be small letter A. I hope you are understanding. This entire CD, if I call it as B and EF is A, suppose if I call DE as B minus 2A, for example, if I call DE as B minus 2A, total from D to C it should be B, but B minus 2A plus A is B minus A. I should remove that minus A also. This should be A. I hope you are understanding, sir. Now, if I want to find the area of this, think little logically. This interior part is nothing but a rectangle where opposite sides are equal. So area of this trapezium is nothing but area of rectangle ABFE. So it is area of rectangle is how much? It is A into H, length into breadth. So it is A into H. Plus, the story will not end here. This is also the thing which I need to consider to calculate the entire area of trapezium, and it's a right angle triangle. Area of right angle triangle is half into base. Base is B minus 2A into height. Height is H. Similarly, this also I should consider. This is also a right angle triangle. Half into base is A. Height is nothing but H. If I combine all these things, now in these two terminologies I have half. Here I don't have half. Multiply by half and multiply by 2. So this becomes AH itself. If I take out that half common factor, if I take half common, here it is 2AH and here it is BH minus 2AH and here it is AH. If I simplify, minus 2AH plus 2AH cancels, AH plus BH is H common factor. If I take, it will be A plus B into H with this half. Very, very important notation. Area of trapezium is nothing but half of A plus B into H. I gave you the little proof also, so that if you don't remember the area of trapezium in your examination, you can derive it then and there itself whenever you require it. I hope the idea is clear. Area of trapezium. Trapezium means it is a combination of two right angles and one rectangle. Add all the three things, you will get the area. Simple, sir. Now, the another family. Now, trapezium is completed. Another family in this quadrilateral is parallelogram. Let us see what is the meaning of this parallelogram. We are learning only little bit of information in everything, sir. With this information, we will try to solve our problems. I might not go into too much high level problems initially itself. I am saying again and again for you people. Now, parallelogram means, let me write the diagram first. Suppose if I name this as A, B, C, D, right? If I name this as A, B, C, D, for example. Now, parallelogram means, if I draw a height here, this I will call it as E, for example. If I draw a height here, this I will call it as F. Again, the same analogy right here. In parallelograms, opposite sides will be parallel. Simple. Opposite sides will be parallel in parallelogram, and opposite sides will also be equal in parallelogram. Opposite sides will be parallel. They will also be equal in length. Sir, only sides will be equal? No. Opposite angles will also be equal. Opposite sides and opposite angles will be equal in parallelogram. That means this particular side, if I call this entire side as, or if I call this entire side as B, for example, then this entire side BC will also be B. Similarly, This AF, if I call it as A for example, EC will also be A. I hope you are understanding. Opposite sides will be equal. This height will be same equal to this height also again. And these two will also be equal in this case. I hope you are understanding. This entire thing is B and this is A. So BE will be B minus A. Here also FD will be, FD value will be B minus A. Same like that. Area of parallelogram, like the way I found out trapezium, if I want to find the area of parallelogram, this entire area plus this right angle triangle area plus this right angle triangle area. If I combine all these things, I will get. So it is half into base. Base is B minus A for this right angle triangle and height is H. Similarly, another right angle triangle is also same. Half into B minus A into H. Then this triangle, this is AECF. It is A and A here, H and H here. It is nothing but a rectangle once again. So it is nothing but length into breadth. Length is nothing but A, breadth is nothing but H. So this half into B minus A into H plus another half into B minus A into H. Totally it becomes B minus A into H. Here it is AH. So it is B minus A. It is BH minus AH plus AH. Minus AH plus AH cancels. Area of a parallelogram is nothing but base into height. Simple, sir. Area of a parallelogram is nothing but how much? Base into height. Sir, what is the difference between parallelogram and a trapezium then? It is very simple. In simple language, if I want to say you people, here it is B into H is what I got for parallelogram. Here it is A into H also is included. And this half is included. Why it is included here? Why not in this case? Because here opposite sides are parallel. Here both the opposite sides are parallel. But in trapezium, only one of the sides, only one of the pair of opposite sides are parallel. Other two pairs are non-parallel, or other pair is non-parallel. I hope you are understanding. Here opposite sides are equal. In this case, opposite sides are only this and this in trapezium, and it is equal here also, but the other side is not opposite side. They are not opposite, they are facing towards a different direction altogether, and they are not even parallel. Because of that you got all these A and half, all those extra things. Because they are parallel and equal here, that thing will be eliminated here and you will be left only with base into height. I hope you are understanding at least little basics of it, sir. Anyway, when we see some problems, you will understand it much more better. Nothing to worry about it. I will definitely make sure that you will understand it in a much more better way. Next, parallelogram is completed. And if you see here, the another type of quadrilateral which is left out is, it is rhombus, right? It is rhombus. Now, same like this, sir. Rhombus is also a parallelogram. Rhombus is also a similar pattern or a similar quadrilateral which is almost similar to parallelogram. I hope you are understanding. Sir, how it is almost similar to parallelogram? Let me show it to you people. Suppose if I draw this rhombus, you can draw a diagram in whatever the way you want. I am drawing it in this way, sir. Suppose if I call it as ABCD. If I call it as ABCD, in rhombus, the properties of rhombus says that it is similar to a square. All the sides are equal first of all. In rhombus, all sides are equal. All the sides are equal. Suppose if I join the diagonals, diagonal is AC. Here the diagonal is BD. The diagonals will bisect at 90 degrees. This is a very, very important property of rhombus. Diagonals, they will bisect or they will meet at how much angle? They will meet at 90 degrees. And another beautiful thing about rhombus is opposite sides are parallel here, right? Yes, opposite sides are parallel. Opposite angles are equal. All these are beautiful properties. It is almost similar to a square, sir. Opposite angles are equal. Now, the other thing is, when this diagonal meet at 90 degree here, when this diagonal meet at 90 degrees, this diagonal AC is dividing this bigger quadrilateral into two triangles, two equal triangles. One of the triangle is ADC, another triangle is ABC. That means ADC, triangle ADC and triangle ABC, they both are equal, or in other words they both are congruent, right? They both are congruent. That means, can I say that because this particular ADC triangle is equal or similar to ABC triangle, area of the entire quadrilateral ABCD is nothing but triangle ADC plus triangle ABC, but both are same, so it is 2 times of area of triangle ABC. You can take any one of the triangle, 2 times of area of triangle ABC. Sir, what is the area of triangle ABC? Area of triangle, we already know it, sir. Area of triangle ABC is, it is half into base into height. If I take this triangle ABC here, base is nothing but base. What is the thing which I am naming the base as? Base is nothing but, in this case, for triangle ABC, base is nothing but this side. AC is the base. What is the height? Height is nothing but, if I name this point as point E, this is my height, right? BE is my height. That means half into base is nothing but AC and height is nothing but BE, right? Height is nothing but BE. But can I also say like this? This is where you will understand so beautifully, and this is where you will actually also realize that you don't actually need to by heart any formulas, but you can derive it then and there equals whenever you require it. Can I also say, what is this BC? Let me see from the diagram. What is this BC? This BC, can I say it as, sorry, BE, right sir, not BC. This is half into base into height. Height is BE. What is this BE? This BE is nothing but, this entire line BD is cut into two equal parts. DE and BE both are same. That means this height BE is nothing but half of this entire line BD. I hope you are understanding. This is half of BD, so it is half into AC into BE is half of BD, or in other language, area of triangle ABC is 1 by 4 times of AC into BD. Sir, I am not interested in finding the area of triangle. I am interested in finding the area of quadrilateral. So area of quadrilateral ABCD is 2 times of area of triangle. That means area of quadrilateral, or in particular that quadrilateral in this case is nothing but which one, sir? Rhombus. It is 2 times of area of triangle is 1 by 4 into AC into BD. So this will be 2 into 1, 2 into 2. In simple language, this is half into AC is one of the diagonal which I will call it as D1. BD is the other diagonal which I will call it as D2. Very, very important point. Area of quadrilateral, in particular, that quadrilateral is nothing but, which one? Rhombus. Area of rhombus is given by the notation half into diagonal 1 into diagonal 2. In simple language, half into D1 into D2. If you remember that, that is sufficient. But I gave you the proof also. Sometimes I will give you the proof so that even if you forget that notation, you can derive it in the examination hall at the earliest possible. I hope I am making sense for you people. I hope I am making very, very clear understanding for you people, sir. Area of rhombus is half into D1 into D2, where D1 and D2 are two diagonals which are intersecting at 90 degrees, and these two diagonals it will bisect each other. Diagonals in a rhombus will bisect. The meaning of bisect is it will divide into two equal parts. That is what you should understand. Now there is another notation which you can remember if possible. The diagonals square, d1 square plus d2 square, the sum of the squares of diagonals is 4 times of, you take any side. If I take side AB, it is AB square, because AB, BC, CD, DA all are same in a rhombus. All the sides are same. So d1 square plus d2 square is equal to 4 times of any one side square, because all the sides are equal anyway. It really does not matter. I did not give you the proof of it, which is not required. When it is coming in problems, we will see it how to tackle it. I hope the basic understanding till this point is very clear for you people. What I have taught you till now is only basics, and that too without solving any problems, only little properties. What are the things which we have discussed till now, sir? Just let us recap for 1 minute of time before we move on to problems. We understood that we are trying to learn mensuration in two-dimensional figures initially, wherein the different geometrical figures are squares, and then it is rectangle, right? Square, rectangle. And we also learned some important properties in triangles, which we have learnt in detail in our geometry class. Then in triangles we have segregated into scale-in triangle. What is scale-in? What is equilateral triangle? And what is that right angled triangle? What is isosceles triangle? We have differentiated all these different type of triangles also. We have seen what is the area, perimeter of all these things. Then we learnt one important thing called as circles, and then we learnt quadrilaterals. In quadrilaterals, squares and rectangles we have learnt it already, and in quadrilateral another 3 extra things what we learnt is, what are the beautiful properties of trapezium, parallelogram. This is the second thing what we learnt. And another thing what we learnt is, the last thing till now what we have learnt is rhombus. Rhombus is a parallelogram. Rhombus is also a square where all the sides are equal. The diagonals of rhombus bisect each other. Diagonals will bisect at 90 degrees. Opposite sides in a rhombus are parallel. Opposite angles will be equal. I told you the proof also to find the area of a rhombus. Area of a rhombus is half into d1 into d2, where d1 and d2 are two diagonals of a rhombus. I hope the idea is very clear for you people till this point of a time.